Good day, geometry. This is going to be about named circles 13. It's going to be about angles that are formed exterior to a circle. And those angles are going to be like this angle right here, and it's going to be formed by two secant lines, or this angle here formed by two tangent lines, or this angle here formed by a secant and a tangent. And as you can see, in every situation, the angle is outside the circle, or if you wish, exterior to the circle. And the segments used to make the angle, or the lines used to make the angle, are all going to be either secants or tangents, or some combination of a secant or tangent. Now, what does the theorem say? The theorem says if an angle is formed in any of these three situations, that angle is equal to 1/2 the difference of the intercepted arcs. So it's 1/2 the difference of the intercepted arcs. So we're going to do a couple of examples and show you how that looks. But what are the intercepted arcs? Here's two arcs. So we take the big arc minus the small arc and then take half of that. Here's two intercepted arcs. Take the big arc minus the small arc and take half of that. And here is two intercepted arcs. And take the big arc minus the small arc and then take half of that. And so these are a subtraction problem. And so you should be able to do this quite easily. And we'll show you a couple of examples. So here's a couple of problems. Take a moment to copy them down, and then let's work through the solution. See if you can do it on your own just based on the theorems. Okay, now that you're back, let's look at these problems. The first thing that I see is that I have two tangents. I have a tangent here and a tangent here, and therefore I want to find the measure of angle 1. And I can see the measure of angle 1 is equal to the difference of this arc minus this arc. And so what we can see is that the smaller arc, going from about here to here, is 99 degrees. Therefore, I need the measure of the bigger arc. Well, when you're doing the two tangents, you can see that you use the whole circle. So the large arc must be equal to 360 minus 99, or 261 degrees. And therefore, applying the theorem, we can say the measure of angle 1 is equal to the difference between the two angles, so 261 minus 99, and then you take 1/2 of that difference. And so now we've set up the problem correctly, and all we have to do is solve it. So we get 1/2, and 261 minus 99 is 162, and half of 162 is 81 degrees. So the measure of angle 1 must be 81 degrees. So let's look at the next problem. The next problem is a little bit trickier. And what we see on this problem is that we have two secants, and that we know the measure of this arc is 68. We don't know the measure of this arc, which is actually arc SU. And we know the measure of the angle is 23. So let's call this, we'll also call it angle 1. Okay? And we'll call this arc TV. And so now we have everything labeled and we can go from there. So the trick here in applying the theorem is we already know the angle here. So we could say the measure of angle 1 is equal to 1/2 the difference between the arcs. Well, that would be 68 degrees for the first arc. And the second arc is the one we don't know. That's the measure of arc SU. And that would be our problem setup. And our variable would be this one. And the measure of angle 1 is 23. So when we set this all up, we get 23 equals 1/2 times 68. And we'll just call the measure of arc SU X for right now. So we can label it as X and then solve for it. Excuse me, I had a sneeze. Hopefully you didn't hear that. I tried to pause the video. Anyway, to solve this out, we just need to work this out using algebra. So I'm going to get rid of the fraction first and multiply both sides by 2, and I get 46 equals 2 times 1/2 is 1, so I'm just left with 68 minus x. And then if I subtract 68 from both sides, I end up with negative 22 equals negative x, and therefore 22 equals x. And so the measure of arc SU equals 22 degrees. So there's our two examples that are very typical of the types of problems you do. And just so you know, this problem is an example of a direct application of the theorem. And this one's sort of an indirect application where you're trying to find the arcs when you already know the angle. So here's another problem that I want you to work on. And your goal in this one is to solve for x. Please notice that you know the measure of the angle and you know the measure of the two arcs and algebraic expressions. And once you find x, then find the measure of the arcs. Now I'm back, and let's look at what you did. So my expectation is that you would have applied the theorem, because I have a tangent line, or excuse me, a secant line and a tangent line that form an exterior angle here. And the theorem says that the measure of the exterior angle, 3, is equal to 1/2 the difference of the intercepted arcs. So that would be 5x minus 6, and difference, subtract 4x plus 8. And so when we work that out, we get 3 equals 1/2 times 5x minus 6, and now we're subtracting 4x plus 8, which is minus 4x minus 8, and then combining like terms, we get x minus 14. Now we want to solve for x, so we multiply both sides by 2, and 2 times 3 is 6, 2 times 1/2 is 1, so we're left with x minus 14, and then we add 14 to both sides. We get 20 equals x. So now that we know that x is 20, now we can find the measure of the two arcs. So the measure of arc AB is equal to 4 times 20 plus 8, which is equal to 88. And the measure of arc CB is equal to 5 times 20 minus 6, which is equal to 94 degrees in each case. And if you take 94 minus 88 and multiply by 1/2, is that not equal to 3? So, and that's my check on the problem. And so the 1/2, the difference of the two arcs equals 3 degrees, so it checks, so I must have done the problem correctly. Okay, that's all for this lesson.